and welcome to another session for the JEE Sprint 2.0. This session is General Inorganic Chemistry 3. We have until now covered General Inorganic Chemistry 1, in which we did the January questions, General Inorganic Chemistry 2 done yesterday, in which we took some another set of typical questions which come in the JEE Mains examination, and in today's section as well we would be trying to take up as many critical concept questions as possible. So without wasting any more time, let's start today's session, and the first question for today's session is this. The first question is about the halogens family. Select which periodic property is not regular in the halogen family moving down the group. Ionization energy, electron gain enthalpy, size and electronegativity. We start off with a slightly easier question. Ionization energy, size and electronegativity have a regular trend down the group. Regular trend, I'm not saying that decreasing or increasing, but if I look at ionization energy decreases down the group, size increases and electronegativity decreases. However, the electron gain enthalpy does not vary in a proper order, but because electron gain enthalpy for chlorine is slightly higher than that of fluorine. And so the trend for electron gain enthalpy is that Cm is more than fluorine, which is more than bromine, which is more than iodine. For electronegativity, it is fluorine, chlorine, bromine, iodine. For ionization energy, it is again fluorine, chlorine, bromine, iodine. Size, it is iodine, bromine, chlorine, fluorine. So the trend which is not followed in our regularity is electron gain enthalpy, and the right answer is D. The right answer is D. So we move on to the next question. The next question is this. In which of the following do not produce NO2 gas with concentrated nitric acid? Concentrated nitric acid का metals and non-metals के साथ reaction के ऊपर बहुत बार question दिया गया है, and in one of my previous sessions, like I guess General Inorganic Chemistry 1, I had taken an example of a reaction of a non-metal with concentrated nitric acid. So let's see how to solve this question. To solve this question, we have to remember that non-metals and metalloids. So I'll write non-metals and metalloids like carbon, tin, phosphorus, arsenic, antimony, sulfur, iodine. All of these would react with concentrated nitric acid to produce oxyacid plus NO2 gas. ये हमने पहले पढ़ा है. Okay. Oxyacid plus NO2 gas. Let's look at the other three metals. These other three sub-elements are the metals which come below hydrogen in the activity series. Now you might wonder that how would they react with HNO3? They react by undergoing oxidation, and in this process they produce a multitude of nitrogen compounds or nitrogenous compounds which are dependent on the nature of nitric acid which is taken. So let's observe it for copper. Copper reacts with nitric acid under 4 different conditions. Okay, it reacts with nitric acid in hot and concentrated. Okay, it reacts with in cold and dilute. It reacts with nitric acid in cold and moderately concentrated, and also it reacts in cold and concentrated condition. All of these are reactions with nitric acid, so I'm not rewriting nitric acid over here. So hot and concentrated nitric acid, the product is N2. The nitrogen containing product is N2. Nitric acid will change to N2. Cold and dilute, it will change to N2O. This will change to NO and this will change to NO2. तरीका याद रखने का बहुत सिंपल है. अब हॉट एंड कंसंट्रेटेड, कोल्ड एंड डाइल्यूट, कोल्ड एंड मॉडरेटली, कोल्ड एंड कंसंट्रेटेड, इसी ऑर्डर को याद रखिए. इस तरह से लिखिए नाइट्रोजन N2O. अब यहां से एक नाइट्रोजन हटा दिया, नेक्स्ट वाले में एक ऑक्सीजन ऐड कर दिया, खत्म. ओके, सो दैट इज द रिएक्शन ऑफ कॉपर विथ नाइट्रिक एसिड इन 4 different conditions. Okay, so let's look at the other entities, Ag, Au. 3 metals coming below hydrogen in the activity series: copper, Ag and Hg react with HNO3. The right answer obviously is D, which is answered by a number of people, that Au will not react or to produce NO2. Au does not react with HNO3. होता क्या है, Ag and Hg ही react करते हैं, and reaction इस तरह से होता है. Ag और Hg will react with hot and concentrated HNO3 and cold and dilute HNO3 to produce hot and concentrated NO. This will produce NO2. Okay, so please do remember that this is the outcome of the reaction. The answer to this question is Au. Please do also remember the various conditions in which copper reacts. Okay, let's move on to the next question. The next question is this: which of the following is incorrectly matched? These are silicates, and silicates के ऊपर question बहुत बार दिए जाते हैं. How to solve this question? Remember that silicates come in 4 different forms. One is known as a normal silicate or orthosilicate. Pyrosilicate, chain or cyclic silicate, and sheet silicate. Okay, there are 4 different types of silicates, and how do we identify their differences? So, orthosilicate basic unit will be SiO4 4 minus. SiO4 4 minus. None of the ends of the tetrahedron will be silicate appears in the form of a tetrahedron. None of the ends of the tetrahedron will be shared by anything else. Pyrosilicate Si2O7 6 minus. This will be the basic unit. This will get repeated. Chain or cyclic silicate SiO3N2N minus. SiO3N2N minus. While sheet silicate will appear in the form Si2O5N2N minus. Okay, now options are given: pyro, cyclic, chain, cyclic. So pyro Si2O7, Sc has +3 oxidation, so this has a total negative charge of -6. If I take this, magnesium is +2, so this total charge is -4. SiO4 2 minus. SiO4 2 4 minus can be written as 2N minus kind of a form, where N is equal to 2. This whole unit, beryllium will carry a charge of +2, +3, +6, +12, so this will be -12. So I can write this whole unit as SiO3 6 2 times 6 minus. So this also is a cyclic silicate. This is pyro, this is chain, this is cyclic. What is this cyclic silicate? This is Si3O9. The total charge is -4. Total charge is -4, so this is incorrect. Okay, so for third question, B option is incorrect. Please do remember this. ये बहुत important shortcut है identify करने का. Let's move on to the next question. Anhydride of nitric acid is prepared by the reaction of HNO3 and P4O10. P4O10 is used as a dehydrating agent. So I take HNO3, it dehydrates HNO3 and will form its anhydride. The anhydride of HNO3 is, my dear students, N2O5. Okay, so anhydride of nitric acid is N2O5, which in the solid state NO2 plus and NO3 minus. ठीक है, ये दो फॉर्म में मिलते हैं हमें. So this might be observed in the gaseous state, but solid state में इस फॉर्म में मिलेगा आपको. So if it is observed in the solid state, NO2 plus is a linear species. N double bond O, O 2 plus minus, ये चीज है. This is NO2 plus, but NO3 minus is this. So linear cation, triangular planar anion, both of the anions. Right answer is C. Right answer is C. Okay, let's move on to the next question. When NaCl is heated with sulfuric acid is used as a reagent in salt analysis, and sulfuric acid is used to dissolve certain salts to detect certain anions. Concentrated sulfuric acid is used for detecting halogens, primarily chlorine, bromine, iodine के लिए हम concentrated H2SO4 लेते हैं. और NaCl के साथ जब हम इसको रिएक्शन करते हैं और MnO2 डालते हैं तो ग्रीन कलर वेपर्स मिलेगा आपको क्लोरीन गैस का. And this is a very important identification test for presence of chloride in a particular inorganic salt. Okay, so what happens in this process is that chloride reacts with MnO2 and changes to Cl2, while MnO2 changes to Mn2 plus. The right answer is this. Chlorine gas is produced. Okay, it's a very simple question. NaCl आप NaBr ले लेते तो भी यही होता. ठीक है? Okay, so let's look at this question. The change Bi3 plus to BiO plus is reversed by adding. This is a very conceptual question. In this question, we have to remember a few important aspect of the chlorides of group 15. So ये अगर हमने chlorides of group 15 लिया है तो क्या information हमें जानना चाहिए? Let's NCl3, PCl3, ASCl3, SbCl3 and BiCl3. You take these chlorides and you react them with water. What happens over here is a displacement reaction, and in this displacement reaction NH3 plus HOCl is formed. इसको याद रखो. ये होता कैसे है? NCl3 में chlorine contains vacant d orbital, so H2O donates its electron on chlorine and displaces the other part. So it's just like a typical SN2 reaction. NCl, Cl, Cl, H2O, ये यहाँ पे गया, ये निकला बाहर, NCl2 minus plus HOCl, H plus, this will take up the H plus to form NHCl2 plus HOCl. Now this reaction will take place 2 more times because there are 2 more chlorine atoms, and so the reaction will lead to the formation of NH3 plus HOCl. PCl3 plus H2O. In this case, since phosphorus contains the central phosphorus is the central atom and it contains vacant d orbitals, so the H2O molecule will rather donate in the vacant. हमेशा सेंट्रल को प्रेफरेंस दिया जाता है, एंड अगर सेंट्रल के पास वेकेंट डी ऑर्बिटल्स प्रेजेंट नहीं है तो पेरिफेरल को के पास जाएगा. नाउ दिस विल फॉर्म H3PO3 प्लस HCl, H2O forms H3ASO3 plus HCl. But these two are very interesting because when they react with water, they interact in an equilibrium. They interact in an equilibrium to form SbO plus Cl minus or BiO plus Cl minus. The reason why this happens is that size of the atom becomes large, so in these cases phosphorus oxygen double bond exists, and any such bond existence when an atom is large is very very unfavorable, so this will happen. The another product over here is HCl, so that gives you the answer. ये इक्विलिब्रियम है, तो अगर हमने एक जो साइड प्रोडक्ट मिल रहा है उसको हमने ऐड कर दिया तो रिएक्शन बैकवर्ड की तरफ मूव कर जाएगा. सो आई हैव टू मूव द रिएक्शन इन द बैकवर्ड डायरेक्शन. व्हाट आई विल ऐड? HCl. व्हाट इज द राइट आंसर टू दिस क्वेश्चन? B. Okay, let's move on to the next question. Bn exists at, Bn is known as boron nitride. A lot of people know that Bn shows graphite like a structure. Okay, a lot of people know that it shows graphite like a structure, but here is a major misconception. Bn, you write X or N, forms graphite like. Bn also forms diamond like structure, and this is known as borazon. Graphite like is boron nitride. You do not need to confuse between borazon and borazine. Borazine is B3N3H6, but diamond like a structure is borazon. The right answer to this question is C. ये दोनों फॉर्म में मिलता है हमें. ठीक है, let's move on to the next question. B2H6 reacts with excess of ammonia at room temperature. Select correct statement about the product. This has to be correct statement about the product. So correct statement about the product would be, let's look at the options. Boron is nitrogen, one of boron is nitrogen, none of the boron is bonded with nitrogen, and last option is B2H6 does not react with ammonia at room temperature, which is the right answer to this question. Okay, B2H6 reacts with ammonia at a temperature of minus 120 degrees Celsius to form something like B2H6.2NH3. इसको ये एक adduct बनता है. This is an adduct. 2 NH3 units are attached to B2H6, which is a white colored non-volatile solid. White colored non-volatile solid, इसको याद रखो. B2H6.2NH3. If it is forming this compound, it will be a white colored non-volatile solid. It's formed at ultra low temperature, somewhere at minus 120 degrees Celsius. If you heat this, you will get B3N3H6. Okay, but if you react with at high temperature, you will get BNX. Okay, you will get BNX, boron nitride will मिल जाएगा आपको. Clear? Let's move on to the next question. So it does not react at room temperature. High temperature पे होता है और minus 120 degree Celsius पे होता है. This is a JEE Mains question. In which of the following exists as a covalent crystal in the solid state? Very easy question. You must have seen this question earlier as well. Sulfur exists as a molecular solid. This also molecular solid. This also molecular solid, except silicon, which exists as a covalent crystal which has a diamond-like structure. Silicon exists as a covalent crystal which has a diamond-like structure. The right answer to this question is silicon. Okay, the right answer to this question is silicon. Let's move on to the next question. Br2 2x minus plus x2 plus 2 Br minus. The above reaction is correct when x minus is. Now this is a question which takes a bit of electrochemistry into consideration. In an electrochemical series, you must have observed that fluorine appears on the bottom of it and lithium appears on the top of it. If you're looking at the relative tendency to undergo oxidation, then lithium will be at the top and fluorine will be at the bottom. Also, if you look at this series from a different perspective, then fluorine's tendency to reduce something will be highest and fluorine's tendency to oxidize something is highest and lithium's tendency to reduce something is highest. Okay, so with this assessment, what we do is, if I look at what is happening over here, bromine is undergoing reduction, so this is undergoing oxidation. Okay, if I take fluorine, chlorine, bromine, iodine, the relative tendency to oxidize something is this. So bromine cannot oxidize chlorine or fluorine, it can only oxidize iodine, and the anion that should be present over here should be iodide ion. The right answer to this question is B. Okay, with this we move on to the next question. Hydrogen peroxide in its reaction with KIO4 and NH2OH respectively is acting as it's a JEE Advanced question for 2014 and एक चीज तो आप आराम से आइडेंटिफाई कर ले सकते हैं इसमें. If I take KIO4 has iodine in +7 oxidation state. KIO4 has iodine in +7 oxidation state, which is the highest oxidation state in which iodine can be present. Highest positive oxidation state in which iodine can be present. So obviously iodine can no longer undergo further oxidation, so anything which is reacting with iodine would only end up reducing it. Okay, so hydrogen peroxide's behavior with KIO4 should only be as a reducing agent. It should be only as a reducing agent. Okay, with KIO4 it should be only as a reducing agent. So KIO4, iodine is in +7. The actual reaction involves conversion of this into IO3 minus. IO3 minus में convert करता है इसको, and so in this case it is converting from +7 to +5. So it is behaving as a reducing agent. What happens when it reacts with NH2OH? Nitrogen is in okay, so if I take NH2OH, what will happen is nitrogen by virtue of this bond will have a +1 charge, by virtue of these two bonds will have -2 charge, so net charge is net oxidation state is -1, and so nitrogen in -1 can undergo oxidation as well as reduction. What happens in this case is nitrogen is converted into NO3 minus. Okay, nitrogen is converted into NO3 minus. So in the first case it is acting as a reducing agent, while in this case it is acting as a oxidizing agent. The right answer to this question is A. Okay, the right answer to this question is A. Let's move on to the next question. The next question is this: under ambient condition. Why I have taken this question is that this is one of the few instances where a particular concept was asked. Under ambient conditions, the total number of gases released as products in the final step of the reaction scheme. In the final step, how many gaseous products are present? What we have over here is XeF6. Now, whenever you see that xenon fluorine compounds are given, xenon fluorine compounds can appear as XeF2, XeF4, XeF6. Okay, they can appear in these three forms. XeF2 undergoes hydrolysis to produce xenon plus HF plus O2. इसको याद रखिए. Xenon plus HF plus O2. The reason why it produces this is because if hydrolysis involves fluorine's replacement by oxygen. So two fluorine go out. So if two fluorine go out, one oxygen should come in. Because each fluorine is bonded by a single bond. So if I put an oxygen, it has to be bonded by a double bond. That means only one oxygen will be present, but XEO does not exist. Okay, XEO does not exist. So this reaction takes place. इसको याद रखिए. XeF6 undergoes hydrolysis to produce XeO3. You can very easily replace 6 fluorine by 3 oxygen atoms. Okay, xenon in +4 oxidation state is midway between the two, so it will undergo disproportionation. And here a very important concept comes, a very sweet trick comes into picture. HCO4, if undergoes hydrolysis, it is midway between +2 and +6, so it will undergo hydrolysis to disproportionate and give rise to 4 different types of products. It will give rise to Xc plus HF plus O2 plus XeO3. यहाँ पे HF भी मिलता है, so HF मैंने यहाँ पे include कर दिया. Okay, so it will give products corresponding to +2 oxidation state hydrolysis and +6 oxidation state hydrolysis as well. That's clear? So let's look at what will happen over here. So complete hydrolysis will generate XeO3. When XeO3 is made to react with a base, what happens? You get an ion like this, XeO4 -1. This is known as a xenate ion. In a xenate, xenon is in +6 oxidation state. When you further perform its reaction in a basic medium, if you leave it in the basic medium, it will change into XeO6 4-, that is perxenate. That will be perxenate ion. Okay, so that will be perxenate ion. Now in this perxenate ion, along with perxenate ion, we would be getting xenon as a gas and O2 as a gas. Xenon as a gas and O2 as a gas. So in this question, the right answer is C. ठीक है? Now xenon perxenate के ऊपर पहली बार ये क्वेश्चन दिया गया था, इसके बाद कभी perxenate के ऊपर क्वेश्चन नहीं दिया गया. Still need to know this. Perxenate is the only entity of, like, if we take xenon units, then in this case xenon is in +8 oxidation state. Highest possible oxidation state में पहुंच जाता है +8 पे. ठीक है? Let's go on to the next question. The product formed in the reaction of SOCl2 with white phosphorus is. It's a very simple question. Okay, SOCl2 with white phosphorus. So SOCl2 when reacts with white phosphorus, it will generate PCl3 plus SO2 plus S2Cl2. Okay, it will form PCl3 plus SO2 plus S2Cl2. The right answer to this question is PCl3. Okay, अब ये S2Cl2 रहता तो ये भी एक आंसर हो जाता. Let's move on to the next question. The least number of oxyacids are formed by. Now chlorine, all of the entities which are trying to form oxyacids end up acquiring a positive oxidation state on themselves because they're bonded to oxygen. But which element among them cannot acquire a positive oxidation state because it cannot acquire a positive oxidation state because of its electronegativity as compared to oxygen? That is fluorine. So the right answer to this question is fluorine. Okay, I do not have to solve the question even. I just need to know that what happens in oxyacid. In oxyacid, the element which is reacting will acquire a positive charge, and this positive charge is not favorable on a fluorine atom because it is more electronegative than oxygen. Let's move on to the next question. XeF4 upon hydrolysis does not give. अभी हमने देखा XeF4 upon hydrolysis does not give. So XeF4 if undergoes hydrolysis, I told you that you should be writing hydrolysis products corresponding to XeF2 as well as XeF6. So XeF2 का hydrolysis product क्या होता है? Xe plus HF plus O2, and Xe, these are hydrolysis products corresponding to XeF2, and what is the hydrolysis product corresponding to XeF6? XeO3 plus HF, ये XeF6 के corresponding है. So which is not obtained? XeO3, HF, all of them are obtained. XeO2 is not obtained, which is the right answer to this question. Okay, xenon hydrolysis के जो questions आते हैं, they are very interesting and you always end up getting them right if you remember few subtle points. Next question. Which of the following is most reactive? We have halogens. Apart from that, there is an interhalogen compound. An interhalogen turns out to be more reactive than halogens because the bond is weaker. So the right answer to this question is ICL. The right answer to this question is ICL. Interhalogen compounds are always more reactive than halogens because of the weakness in the bond. Next, which of the following statements regarding H2O2, from the following statement regarding H2O2, choose the incorrect statement. It is again JEE Mains 2015 question. H2O2 is an important topic. Please don't ignore it because H2O2 से आपके पास questions आएंगे. So, which is the right answer to this question? It has to be stored in. We have to identify the incorrect statements. It has to be stored in plastic or wax lined bottles in dark, which is correct. H2O2 decomposes in presence of sunlight. Also, if there is glass and there is some kind of an impurity, it will react with it. Glass may allow light to pass through. It has to be kept away from dust. It catalyzes the decomposition of H2O2. It can only act as an oxidizing agent. No. Yesterday I told you that H2O2 can act as oxidizing as well as reducing agent in acidic as well as basic medium. It decomposes on exposure to light, which is correct. So right answer to this question is C. Okay, the right answer to this question is C. Let's move on to the next question. Which of the following occurs as a consequence of inert pair effect? I explained this to you yesterday that inert pair effect involves a reluctance of the ns orbital electrons to undergo unpairing. Okay, now because of that, a lower oxidation state is more favored as compared to the higher oxidation state. As we go down the group, the tendency to show lower oxidation state increases. Now, if I take these statements, which of the statements are correct? Now, between Sn2 plus and Sn4 plus, which would be a more stable oxidation state? Carbon, silicon, germanium, tin, lead. These this element tin is second last in group 14. The tendency to show +2 oxidation state increases, the tendency to show higher oxidation state decreases, so this oxidation state is more favorable. So if any compound Sn4 plus is taken, its natural tendency would be to convert into Sn2 plus rather than stay as Sn4 plus. Okay, so ये इसमें convert होना चाहेगा और ये process favorable होगा. So if this process favorable, so Sn4 plus is taking up electrons. So Sn4 plus will be acting as a oxidizing agent, which is very correct. Sn2 cannot act as a reducing agent because if you see that Sn2 plus would act as a reducing agent, it would want to convert to Sn4 plus, which is not a favorable reaction. This statement suggests that SN2 plus is wanting to convert into SN4 plus, लेकिन ये ऐसा होता नहीं है. SnO2 is amphoteric. Amphoteric nature cannot be explained using inert pair effect. PbO2 is an oxidant. PbO2 is an oxidant. We can explain it using this because it is Pb4 plus. Pb4 plus is less stable than Pb2 plus. So Pb4 plus would want to take up an electron by oxidizing something else, so it will behave as an oxidant. CCl2 is unstable, but PbCl2 is stable. Very right, because CCl2 will have carbon and +2 oxidation. The top members of the group will always favor the higher oxidation state, lower members favor the lower oxidation state. So this statement is also correct. The right answer to this question is BDE is the right answer to this question. Okay, let's move on to the next one. Hydrolysis of 1 mole of which of the following required maximum volume of 1 m NaOH for complete neutralization and maximum volume of 0.1 m dichromate for complete oxidation? So it's a very beautiful question. A lot of the students, I'm pretty sure, would end up making a mistake, and this is where we need to know what is gonna happen. Now if I take SO2Cl2, and react it with NaOH, this will displace Cl and OH will replace Cl, and we would get H2SO4 plus HCl. Okay, I will get 1 mole of this plus 2 moles of this. Obviously, क्योंकि एक यूनिट हमने इसका लिया है, and there are 2 chlorine atoms, तो 2 chlorine atoms will be replaced by 2 units of OH minus. ठीक है, this is what will be happening during the hydrolysis of this compound. Now both of these compounds will react with 3 moles of NaOH. They'll react with, this is a dibasic acid, this is dibasic, this is monobasic, so 1 unit of dibasic will produce 2 H plus ion, so this will react with 4 moles of NaOH. Okay, 4 moles of NaOH. Calcium chloride hydrolysis will produce calcium hydroxide, but NaOH के साथ उसका रिएक्शन नहीं होगा, तो इसको हम हटा देते हैं. ठीक है, COCl2 will produce what? C double bond O, OH, OH plus 2HCl, but this compound will not be stable. Carbonic acid is not stable, H2CO3 is not stable, so it will disintegrate rapidly to form H2O plus CO2. Disintegrate rapidly to form H2O plus CO2. This CO2 can react with NaOH to form Na2CO3. Okay, so कितने मोल्स हमें लगेंगे? 2 मोल्स लगेंगे यहाँ पे, and 2 मोल्स यहाँ पे लगा. So in total over here also we require 4 moles of NaOH. SOCl2 will produce, SOCl2 में SO2Cl2 से एक ऑक्सीजन कम है, एक डबल बॉन्डेड ऑक्सीजन कम रहता है. सो यहाँ पे क्या मिलेगा? एक डबल बॉन्डेड ऑक्सीजन हम अगर यहाँ से हटा दें तो I will be getting something like this, HOS double bond OH. This is H2SO3, which is a dibasic acid, and plus 2HCl, 1 mole of this. Again, dibasic acid, 1 mole plus 2 moles of HCl, it will react with 4 moles of NaOH. So A, C and D, all of them will react with 4 moles of NaOH. 4 moles of NaOH. But when it comes to reaction with dichromate will react with something which would want to undergo oxidation. Carbon dioxide does not want to undergo oxidation. Carbon already is in +4 oxidation state. Sulfur +6 oxidation state does not want to undergo oxidation. Which entity would want to undergo oxidation? जहाँ पर एक lower oxidation state में उसका central atom present है, that is sulfur over here, which is present in +4 oxidation state. So dichromate will end up reacting only with the product obtained by the hydrolysis of SOCl2. So the right answer to this question is D. Okay, the right answer to this question is D. It's a very beautiful question. Please try to solve it again. Let's move on to the next question. Select the correct order of dissociation constant in aqueous solution. It's a very simple question. These are hydrides of group 16. Now जैसे जैसे हम नीचे आते आते हैं size of atom increase करता जाता है and the strength of central atom with hydrogen, the strength of the bond decreases. So the bond between tellurium and hydrogen will be very very weak as compared to bond between hydrogen and oxygen, and so the bond will break very easily. If the bond breaks easily, I will end up getting a H plus ion very quickly, and so the acidic strength down the group will always increase. So the right answer to this question is B. Okay, Ka represents acid dissociation constant. It also measures the tendency of the entity to give out H plus ion. So H plus ion will be given out if the bond is weak. The same trend is followed in group 17. HF, HCl, HBr, HI bond is weak, so it will break very quickly, and because of that HI turns out to be the strongest acid. Clear? Let's move on to the next question. B3N3H6 solution plus solution of hydrochloric acid. Select the correct statement. ये आप लोग जानते हैं क्या होता है. B3N3H6 is known as borazine or borazole. B3N3H6 is also known as inorganic benzene and it is known to be more reactive than normal benzene because it undergoes addition reaction. So B3N3H6 will be like this. Okay. Now, when it reacts with HCl, addition reaction will take place, and where would H plus and where would Cl minus go and get attached is very very easy to know. Nitrogen with positive charge, the entity would continue to have the positive charge on itself. So nitrogen would rather bond with hydrogen, and chlorine will bind with boron, so that it continues to have that negative charge on itself. So in this scenario, because if I break this bond, this becomes neutral and this becomes neutral. So बोरॉन इज इलेक्ट्रॉन डेफिशिएंट. अगर हम इस बॉन्ड को हटा देते हैं और ये चार्ज हमने हटा दिया, द नाइट्रोजन इज न्यूट्रल, बोरॉन इज न्यूट्रल. बोरॉन विल हैव वेकेंट ऑर्बिटल इन विच इलेक्ट्रॉन कैन बी डोनेटेड बाय Cl माइनस, बट इट कैन नॉट रिएक्ट विद H प्लस बिकॉज H प्लस तो वैसे ही भूखा नंगा है भाई. सो H प्लस इज not having electron. Boron does not have lone pair of electrons to donate. So that is the reason chlorine will go and attach itself to boron and hydrogen will attach itself to nitrogen. The right answer to this question is the addition reaction produces this in which Cl is bonded to boron, which is the right answer. Okay, let's move on to the next question. Hydrolysis products of which of the following compounds produces white precipitate with Tollens reagent? Simple question, very to the point question, very easy to identify. Silicon carbide does not undergo hydrolysis. Silicon carbide is an abrasive, very very hard substance. It does not undergo hydrolysis. What happens in the other cases? Be2C, what will be the product? How do we identify? एक चीज देखो, यहाँ पे +2 चार्ज है. So total कार्बन के ऊपर टोटल चार्ज कितना हुआ? -4. Okay, कार्बन के ऊपर टोटल चार्ज -4 हुआ. If carbon with -4 is added to water, it will combine with 4H plus ion because -4 को 4H plus से न्यूट्रलाइज करेंगे हम. So I'll get CH4. Similarly यहाँ पे देखिए Mg2 2 plus charge. So over here the total charge is -4. 3 कार्बन के ऊपर टोटल चार्ज -4 है. इसका मतलब ये कि each carbon ideally if it want to form CH4 should have a -4 charge on itself. But if 3 carbons are having -4 charge, that means some of the few valencies are satisfied, and that will happen only when the bonds are arranged like this. And this will generate CH3 C triple bond CH. Propine मिल जाएगा आपको. Al4C3 plus 3, so this will be total -12. Each carbon will have -4 charge. Each carbon if is -4, that means none of the valencies are satisfied. It will form CH4. अगर valency satisfy हो गया देन कार्बन कार्बन का एक कंपाउंड मिल जाएगा आपको. लेकिन अगर कोई भी वैलेंसी सेटिस्फाई नहीं हुआ, कार्बन इज हैविंग ऑक्सीडेशन स्टेट ऑफ -4, देन CH4 वुड बी प्रोड्यूस्ड. इनमें से कौन सा टॉलरेंस रिएजेंट के साथ रिएक्शन करेगा? दिस वन. दिस विल रिएक्ट विद टॉलरेंस रिएजेंट. टर्मिनल अल्काइंस रिएक्ट विद टॉलरेंस रिएजेंट टू गिव अ व्हाइट प्रेसिपिटेट. ठीक है, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. द नेक्स्ट क्वेश्चन इज दिस. NH3 produces dark blue solution when reacts with copper sulfate. If pH3 is used in place of NH3, then what will happen? It's a fact based question. This observation you have to remember. NH3 copper sulfate का reaction सभी को मालूम है. It produces blue colored intense blue colored solution because that is known as cupramine. Cupramine CuNH3 प्लस का एक सॉल्ट आपको मिल जाता है. CuNH3 2 प्लस का एक सॉल्ट आपको मिलता है. But when it reacts with pH3, the product obtained is Cu3P2. Okay, Cu3P2. Cu3P2 is a black precipitate. Okay, this is a fact-based question. Please do remember this. Cu3P2 is produced when phosphine is interacting with it. It does not form a coordination compound. Next. K4FeCN6 reacts with dilute H2SO4. K4FeCN6 reacts with concentrated H2SO4. There are two gases which are obtained. What are the products? Now, again, K4FeCN6 is an important compound and its reaction with H2SO4 has been asked in a number of examinations. Okay, some of the other way इसको modulate करके question दे दिया जाता है. What happens is that when it reacts with dilute H2SO4, you will get K2SO4, FeSO4 plus HCN. But when it reacts with concentrated H2SO4, you will get K2SO4 plus FeSO4 plus CO. Water भी आपको मिल जाता है. The right answer to this question is HCN and CO. Okay, please do remember the answer to this question because ये एक fact है और इसको infer करने के लिए आपको ये reaction जानना जरूरी है. Okay, so with this we conclude today's session and we'll conclude the session with a quote that success is struggling from failure to failure without giving up enthusiasm. Inorganic chemistry is where you keep on failing because you miss out on few critical points. I hope you have enjoyed all the sessions until now that we have taken on inorganic chemistry from chemical bonding until this point, and we would be taking another last session on salt analysis. And every time what you do is keep trying, give it to your best. And don't worry if you're not able to solve out of 10 questions all the questions. Even if you solve 5 questions and balance it by solving good number of questions physical and organic, I'll be very happy with you. Okay, so what you need to do is do not give up while studying inorganic chemistry because it is very, very vital. Okay, so if you have liked the video and if you have found the content enjoyable, please do like, share and subscribe. Also, a lot of information and everything, the PDFs are available on the Vedantu doubt solving app, not the Vedantu app, the doubt solving app. So please do install and try to make use of it as much as possible. So this is Saurav Goswami signing off, and I wish you all the very best and you have a lovely day ahead. Bye bye guys.